Hello everyone. In this video, we're going to continue discussing some more questions in preparations to join ASMOPSS. So let's start with question 1. A family has 3 children. Their ages in 2020 were in the ratio of 3 to 4 to 5. The sum of their years in which they were born in is 6012. So this should be is. Determine the sum of the children's ages in the year 2016. So if we know that the sum of the years in which they were born is 6012, we need to know first in what year each of them was born in. So for the youngest child, the age is 3 units, or we can say that the age is actually 3x. And the same goes to here, 4x for the second child, and the eldest child's age is 5x. So by knowing that, we can find the year in which each of them was born in. So for the youngest child is 2020, the current year, minus the age, and then add it to the year in which the second child was born, 2020 minus 4x, and also add it to the year in which the eldest child were born in. So that is 2020 minus 5x. That is equal to 6012. So if we simplify the equation, it is 6060 minus 12x is equal to 6012. Then we can also say that 12x is equal to 48. So that means x is equal to 48 divided by 12, that is 4. So what is the x then? X means the value of the units, right? So if we have to determine the sum of the children's ages in the year of 2016, let's find the current age first. So after knowing x, now I can write 3x as 12 years old, and 4x is 16 years old, and 5x means 20 years old. So 2016 means 4 years ago. So 4 years ago, the youngest child was 8, plus the second child was 12, and the oldest child was 16. So the sum of the ages is 36, which is option C. Okay, now number 2. How many 4-digit numbers are there in which the sum of the first 2 digits is the same as the sum of the last 2 digits? Since what we're looking for here is the sum of the first 2 digits must be the same as the sum of the last 2 digits, then I will break it down into 2 groups, the first 2 digits and the last 2 digits. And if we are looking for the sum, so the sum can start from 1. All right, that means the numbers are 1, 0. Okay, 1 plus 0 is 1. And then the last 2 digits can start with 1, 0 or also 0, 1. So now the combination from the first sum, which is 1 here, I will write here, when the sum is 1, then the number of combinations is 1 times 2, which is 2. So I'm trying to show you the pattern that we can find here. Now, for the next sum, we're working with 2 because we can have a sum of 2 in the first group and second group, right? It can be 1, 1 or 2, 0. Okay, then here it can be 1, 1, 2, 0 or 0, 2. So now you see that when the sum is 2, the number of combinations we have is 2 times 3, which is 6, because it can be 1, 1, 1, 1, 1, 1, 2, 0, 1, 1, 0, 2, or 2, 0, 1, 1, 2, 0, 2, 0, 2, 0, 0, 2. So there are 6 different combinations. And if you want to find the number of combinations, you can find the number of possibilities in the first group multiplied by the number of possibilities in the second group. Now we're looking for, I'm sorry, I haven't written the sum of 2 there. Now I will put a little more space here because we will need more. Okay, now we're working on finding the sum of 3. So when the sum is 3, then there are even more possibilities because it can be 1, 2, or 2, 1, 3, 0. It cannot be 0, 3, right? A number doesn't start with a 0. While the possibility here can be 1, 2, 2, 1, 3, 0, or 0, 3. So you see, because we still involve the number of 0, then the number of possibilities on the second group in the last 2 digits is always one more. Okay, then for that, from this, we can see the pattern that is formed. When the sum is 3, the number of possibilities is 3 times 4, which is equal to 12. And if we continue that, when the sum is 4, it's 4 times 5, 5 times 6, 6 times 7, until we get to when the sum is 9, then the number of possibilities is 9 times 10, which is 90. It is safe to assume this because when the sum is 9, we are involving 9, 0 and 0, 9. So 0 is still included in there. But look at the next pairs of sum. I will write here on the left. So now what if the sum is 10? We will take this as an example so you can see the pattern. When the sum is 10, then we will not involve any 0 anymore. We cannot put 0, 10, 0 there. It will be a 5-digit number, right? So the digits that are possible is 554664, and then 3773, and 2882, and 9119. So now you see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 pairs, and the same will go here too. No additional pair. So that means when the sum is 10, the number of combination we will have is 9 times 9. Now this changes the sign. It changes the pattern, I mean, right? It becomes a square number. So 9 times 9, and until the greatest sum you can get is 18, when the digits are 9999, 9999. That's the greatest 4-digit you can get, right? And there is only one possibility in there, which is 1 square. So if you notice, actually, starting from when the sum is 10 until the sum is 18, they are square numbers from 1 squared to 9 squared. While from the sum of 1 until the sum of 9, then it is 1 times 2. So the number multiplied by the number plus 1, right? Then we can safely add them all if you want to do the normal addition, okay, which is simpler. There is actually a shorter way, a formula to find the sum of all that, but I'm not going there. Okay, I just don't want to confuse you. Now we can add all of them. So 2 plus 6. So this is 1 times 2, 2 times 3, and we can continue that. Okay, then 3 times 4 is 12, 4 times 5 is 20, 5 times 6 is 30, 6 times 7 is 42, then 7 times 8, 56, plus 8 times 9, 72, until 9 times 10, 90. And then it changes to the square number 9 squared, 8 squared, and then 7 squared, and then 6 squared, 5 squared, 4 squared, 3 squared, 2 squared, and 1 squared. So we just simply have to add them. And there's actually an easy way to add, that is making tens or hundreds. So that's what we're going to do. Okay, now I know that 2, 6, and 2 will make a 10. So 2 plus 6 plus 12, that makes 20. Okay, 20 plus 20 is 40. 40 plus 30 is 70. So now I've got 70. Okay, I will write there 70 that I've got. And then I'm trying to find other pairs. 1 and 49 makes 50. So I will add 50 to that. And then do you see other pairs that makes tens? Now I have 42, 56, and 72. 2 plus 6 plus 2 makes 10, right? So 42 plus 56, that's 98. 98 plus 72 is equal to 170. And then now I have 90, so I will add 90 to that. And then we have 89 and 9, that's another 90. So see, I'm collecting the tens, right? 64 and 36, that makes hundreds. So 100. And then now I only have to add the last one. 16 plus 4 is 20. 20 plus 25 is 45. So now let's add all of them. 90 plus 100, 190, plus 90 again, 280, 350, 400, 400, and then 570 plus this, that is 615 different possibilities. Okay, so there are 615 four-digit numbers. Number 3, there are 5 kids playing some games. At the beginning, every kid has some number of candies. After every game, the loser doubles everybody's candies. They played 5 games and everybody lost once. After 5 games, everybody has 128 candies. How many candies did all 5 kids have before the games? Now, the key here is that it says in the beginning, every kid has some number of candies, and after every game, the loser doubles everybody's candy. So what it means is that the number of candies just go around the 5 kids. Let's say there are 5 kids. Okay, so let's say the first player here loses, and then he will double everybody's candies. So that means everybody's candies increase in the number while his decreases, and so on and so on. So what it means is that none of the candies actually go outside of the 5 students here, of the 5 children here. So that means that the total number of candies in the beginning and at the end of the 5 kids altogether remain the same. So we can say that the number of candies is just 5 times 128, because we know in the end everybody has this many candies. So that is equal to 640 candies, which is option C. All right, I'll see you in the next video.